going to be sort of jumping ahead a little bit of where you are in class today, but that doesn't matter. It's not the end of the world. All right, so let's just go through this again. And I'm going to discuss the cubic function and its characteristics in more detail at the end of our lesson. What I really want to get into now is what it means to solve a cubic equation. So all cubic equations come in the standard form, ax cubed plus bx squared plus cx plus d equals 0. All right, and just like we solve a quadratic equation by factorizing and making it equal to 0, so letting y be equal to 0 because y is equal to 0 all the way along the x-axis, so cubic equations follow exactly the same process. We have to factorize them, we have to make it equal to 0, and then once we've got our bracket times our other bracket, then we can then calculate what the x-intercepts are going to be. Before we jump into that, I just want to point out to you, like it says here, cubic equations have at most 3 real solutions, but they have to have 1. Okay, so it has to have at least 1, and it can have as many as 3. It can also have 2. So if I take a cubic function that is shaped like this, all right, and I'm going to draw 3 different lines here. Okay, so the first line I'm going to draw is going to be green. How many times does the green line intersect the pink one? Only once. So this is a situation here where I have one x-intercept, right? Or I could have a situation like this matrix. Okay. Oh gosh, hang on, sorry, that didn't work out. Okay, just 1 second. I just need to move that line. It's not exactly in the right place. Oh, of course, now doesn't want to go through exactly. So this pink line over here, I don't know why it's doing that. Sorry, let's do this. There we go. So now I've got 2 x-intercepts. Okay, so a situation where I can have 2 values for x, or matrix, I could have a situation like this. Okay, so in other words, let's draw another line. We'll take purple. Okay, and let's do, it's going to have to look like that, I guess. Hang on, let's just move it again. Let's just move it up a little bit. Okay, so if my x-axis is now my purple line, okay, how many x-intercepts do I have? I have 1, 2, 3. So I have to have at least 1. Can have 2, or I could have 3. Okay, so every time you are solving a cubic equation, you are expecting at least 1 solution. There can be 2, or there could be a maximum of 3 solutions. We have to use factor theorem to help us solve cubic equations when we do not know what the linear factor of the cubic polynomial is. All right. Now, this first equation is actually much easier than it looks. We don't need factor theorem to be able to solve this one because we have an x in every single term. So first step, okay, get it into standard form. So that means taking 2x cubed plus 5x squared minus 3x and making it equal to 0. Can you see in this case as well, I'm just pointing this out to you, that the value of d is also equal to 0 in this particular equation. Okay, this letter d over here, you'll see as we work through this section, that represents the graph's y-intercept, but that's something we'll discuss towards the end of this lesson. All right, so I can see that in each one of these terms there is an x. So I'm going to take x out as a highest common factor. That's going to leave me with 2x squared plus 5x Okay, I don't know why my screen has done that. It likes to do that every now and again. Sorry, guys. Hold on one moment. So frustrating. Okay. There we go. So I've got 2x squared plus 5x minus 3 equals 0. All right, so now I need to factorize my trinomial. So I'm going to have 2x here, x here equals 0. I need the factors of 3, which has to be 3 and 1. In order to get the plus 5 in the middle, I'm going to put the 3 here and the 1 there, so that when I do the O part of FOIL, I get plus 6 minus 1x to give me the plus 5x in the middle. And here you can see a cubic equation that has 3 solutions. All right, matrix, so either x is equal to 0 or x is equal to 1 over 2 or x is equal to -3. Right, and it's really important that you do write that. Okay, so you write x is 0 or x equals a half or x equals minus 3. Right, if you do this, x equals 0, semicolon 1 over 2, semicolon -3, you're going to get penalized. Okay, so do not write that. Okay, you have to write it's this or this or this or this. Okay. So that one was fairly easy as far as cubic polynomials go, right? Remember, don't leave off the equals 0. There's our solutions, and then there would be a mark for taking out our x. Okay, everybody happy with that? So that's a situation where we've got 3 roots. So like the purple graph, the purple x-axis that I was showing you over here. All right, so that sort of equation, it's like this situation here with the purple one. 3 distinct, separate x-intercepts. Now we're going to have a look at example number 2. So we've got x cubed minus 8. Okay, so now in this example over here, this is difference of cubes, but an easier way to solve this would be to take the the 8 over to the other side, cube root the left, cube root the right, and x will be equal to 2. Okay, so here's an example of a cubic equation where there's only one solution. Right, that would be really, really easy. I don't think they would give you something as simple as that in an exam. But then again, I'm not setting your exams, so I don't know, but I wouldn't have thought so. So that's like the situation over here with the green. Okay, there was only one x-intercept. Okay, and now we want to have a look at a situation, right, where there's going to be 2 x-intercepts in this particular equation. First of all, before we get started on solving this, how's everybody feeling so far? Is this making sense? Are there any questions? You guys okay? All right, cool. All right, lovely. Okay, nice. Okay, so interrupt me if I don't make sense, okay? Or if I write something that's weird and you know is ridiculous, please stop me, okay? What's missing here? What do we not have here in this example? There's a term that's missing. Which term is missing, guys? Aha, quite right. Can you see, Levy? X squared term. So when the x squared term, if the x squared term is missing, because we need the x squared term, it's very important to us. The x squared term is missing, we give it a coefficient of, what coefficient do we give it? Can't give it a coefficient of 1, can you see? We have to give it a coefficient of because remember, it's not there. So we give it a coefficient of 0. Does that make sense? Indeed. Okay, so 0x squared minus 12x plus 16 equals 0. Now it's in standard form. Okay, can you see it? All good. All right, lovely, lovely, lovely. So now it's in standard form. We don't know what a linear factor of this expression is. So here we didn't need to know a linear factor because we could take the 8 over to the other side and cube root both sides. Here we didn't need to know a linear factor because we could take out an x. So here is the first situation where we do not know what the linear factor of this equation is. And that's why we've got to pick up our calculators. All right, so we're going to sub in values of x that give us 0 as an answer. So in other words, we are fishing for one of the x-intercepts by trial and error. This is something that we never do, but in this situation here, in this case here, there is no other way for us to be able to do this other than by trial and error. Okay, so we're looking for the f of something that gives us 0 as an answer. So sub in 1, sub in minus 1, sub in 2, sub in minus 2. It's got to be a number that goes into 16, so we wouldn't use 3. We could use 4, we wouldn't use 5, but hopefully by the time we've tested 1, 2, and 4, we've already got it. So pick up your calculators. And let's see what you guys come up with. Aha. Good, Mohammed. Okay, so 2, it should be negative 2. No, sorry, yeah. F of 2 gives you 0, sorry, yes. Okay, so in other words, if I say that this is f of x, okay? So you're saying to me that f of 2 equals 0, which it does. You're both correct, okay? What does that mean for us? It means that x minus 2 is a linear factor. Okay, so we've got to remember to change the sign, because in order to get this 2 over here, we had to take our bracket and make it equal to 0, and then take that 2 over to the other side. Okay, so that's why x minus 2 is a factor. So now we've got x minus 2 is one of our factors, and now it is our job to work out the coefficient of the x squared term and the b term, and to work out what the coefficient of, work out what c is, our constant term, in order to be able to solve this equation. Now, there are many different ways to be able to do this matrix. Well, not many, there's 3 ways. So first of all, you could do it by long division, but why anybody would want to do long division, I don't know, but you can. Or you can do something called synthetic division, which is a good method, but there are a couple of instances where synthetic division will not work. That's why I always teach by inspection, because inspection works every single time. So this is the 3rd method, by inspection. So by inspection means by looking at something, right? So in order to get this x cubed term, we obtain this x cubed term over here by multiplying the first term in the first bracket with the first term in the second bracket. That's the only place where x cubed comes from. So in other words, ax cubed, the product of x and ax squared, is then going to be equal to, and now this is the inspection part. Okay, so now we go and have a look what it's equal to. All right, it's equal to 1x cubed. So therefore, we deduce matrix that A must be equal to 1. Okay. The order you then do B and C in doesn't matter. Sometimes teachers do C first, sometimes they do B first. It really doesn't matter. I think what I'll do is I'll leave B to the end. The only way that you can work out what C is, okay, is that it comes from multiplying this number over here and that number over there, and it gives us this value over here. Okay, so in other words, minus 2 times C is equal to 16. Divide both sides by -2, and that means that C has to be equal to -8. And now we're going to work out what B is. Now, B comes from more than one place, unlike A and C. What we've got to do here is two things. First of all, we have to multiply x with bx to get bx squared. And we have to multiply -2 with ax squared. So in order to work out B, we need to know A. So -2 times 1x squared, because remember A is equal to 1 in this case. This gives us plus, oh, sorry, it doesn't give us plus at all. It gives us minus, doesn't it? Minus 2x squared is going to be equal to, and this is where that 0x squared was so important. Okay, so we observe that it is equal to 0x squared. Does that make sense to everyone? This is the difficult bit, I guess. And once we have this matrix, we can drop the variable and work with a coefficient. So what I mean by that is b minus 2 equals 0. And now we can work out that b is equal to 2. Right, and that is the easiest way for you to be able to factorize this. So now we've got x minus 2, our linear factor. Then a was equal to 1, so that's 1x cubed. B is equal to 2, so that's plus 2x. And c was minus 8. Okay, and then, ooh, not cubed. Why did I write cubed? Sorry, I meant squared. Okay. And now we've got to factorize our trinomial. Okay, so if it does factorize, we must factorize it. Sometimes it will factorize, sometimes it won't. If you have one of your turning points, both of your turning points below the x-axis or above the x-axis, then that trinomial will not factorize. But if there are two factors, if there are 2x intercepts or 3x intercepts, then it obviously has to factorize. Okay, so here, this was going to have to be x plus 4 times x minus 2 is equal to 0. Okay, hope we're going to go back and we're going to explain that to you now. And the other thing that's important here, matrix, is this. We're going to talk about this later on in this lesson if we have a chance. Okay, so this doubling up of these brackets is a significant event. It means something important for us, right? But I'll talk about it later on. So now we have two solutions. Either x is equal to 2 or x is equal to -4. Okay, so now you've seen basically one example of each. Okay, so 3 solutions, 1 solution and 2 solutions. Okay. Okay, can you see? Let's shame you lost. All right. Can we also use the quadratic formula? Absolutely, Pumeza. Okay. Absolutely, you could. But only, Pumeza, you can only use the quadratic formula to solve the quadratic. So you wouldn't be able to use the quadratic formula to solve the whole thing. So the quadratic formula will work for this bit that I'm just highlighting in turquoise now. Okay, now I see I've lost Kanyisile, that's fine. And I've also lost, hang on a second, Hope. Ma'am, I don't understand where f of x equals 2 comes from. Oh, you mean where f of x equals 0 comes from? Hope, do you mean this bit over here that I've just put a circle around? Okay, all right, Rory, all right, Kamisile, not a problem. Okay, we can certainly go through that again. all right? And if the others are, if it's making sense, then you guys can carry on with something else. So what's happening at this stage over here is you are looking for your linear factor. So in other words, you are looking for this bracket over here so that you know how to write your cubic expression as a linear times a quadratic. Okay, so the linear is this one here times your quadratic factor is that one over there. So in other words, like I was saying earlier, you are fishing for one of your x-intercepts by trial and error. Okay, now that is not something that we do in maths. We don't solve things by trial and error. All right, we're not allowed, in fact, in the CAP syllabus, we're not allowed to solve things by trial and error, except in this situation here, when we are factorizing and solving a cubic equation. If we do not know what our linear factor is, then we have to go fishing for it. Okay, so in other words, when I say fishing for it, we need to sub in values, okay, in place of the x in order to see what gives us 0. So what someone has done on the calculator is this, all right? They have said in standard form like this, if we've got x cubed plus 0x squared minus 12x plus 16 equals 0, we are subbing in 2. Okay, so in other words, 2 cubed plus 0 times 2 squared minus 12 times 2 plus 16. Okay, as it turns out, this gives us 0 as an answer. So if when we sub 2 in and we get 0 as an answer, it means that x minus 2 is one of our linear factors. Okay. And then we have to then go and work out the coefficients of the x squared, the x term, and then obviously the c term in our quadratic factor. Okay, yes, Celia, what question did you want to ask?
Trying to unmute. Yeah, hover over her name and click on mute.
Ma'am.
Hi, Celia.
How are you, ma'am?
I'm fine, and you, my darling?
I'm good, ma'am. Ma'am, let's say we got a negative number. Would we say x plus the number, or would we still have to say x minus the number?
No, so in other words, Celia, what you could also have in this particular situation is this. So f of negative 4 could give you 0 as well.
Mm-hmm.
All right, because x equals negative 4 is also a solution. So if f of negative 4 gives you 0, then it means that x plus 4
okay.
could be another linear factor. Okay, so that's what could happen, Celia, is that, you could come along and you could find, 2 gives you, when you sub in 2, you get 0 first. So you use x minus 2 as your linear factor. And then Cassandra can come along and she, for some reason, discovers that when she subs in negative 4, she gets 0 as an answer. So she uses x plus 4. Then her coefficients will be different in her trinomial to yours, but you'll still get the same answer at the end.
Okay, ma'am.
Does that make sense?
Yes, ma'am.
Okay. All right. So as long as your linear factor is indeed a linear factor, then your trinomials may differ, absolutely, but your final answers will all be the same. Okay, is everybody feeling a little bit better? It's like learning to drive a car, guys. You just got to keep practicing. Okay, the more you do it, the easier it becomes, I promise. Okay, so good stuff, Thelma. All right, so now we're in a situation where we've got 2 solutions. So then it would be like the orange one. Okay, this orange x-axis. Now, this is the part that I wanted to discuss with you. Can you see that for there to be 2 x-intercepts, the 1 point, so in other words, this one over here, let me talk about this point over there. That one over there is not only an x-intercept, it is also a turning point. Okay, now when that happens, okay, you have a situation like this one that we've got over here, and this bracket that repeats itself, so the x minus 2, this over here is going to be your x-intercept that is also a turning point. Okay, and very important that you know that and you understand that and you're able to work with it. Okay, so if a bracket repeats itself, it means that that solution for x is not only an x-intercept, it is also a turning point. Okay, all right, now, do we want a little bit of practice before we get started on the cubic function characteristics? I think we should do that. So here, I is easier than j. So I think just do 1. And we'll practice this, and then we will move on and we'll talk about the characteristics of a cubic function. Guys, bear in mind that this sort of question where you are determining the x-intercepts or solving for x is going to carry like 4, maybe sometimes 5 marks, okay? You are not going to get 4 or 5 marks by writing down the answers only because you used your calculator. You've got to show the steps, okay? All right, off you go, and Elisa and I are here for you. Let us know when you are done. Okay, so just do 1. Either do I or do J. Okay, I'm going to start working through I. Don't think this is going to factorize. That's it, Kamisile. Okay, quite right. So I just pressed the SD button, but you and Hope have got the correct answers. Okay, for I. So there were 3 different solutions. So either 0, or 1,24 or -3,24. So in a situation where it does not factorize, you can use, I'm talking about the quadratic factor. The quadratic factor does not factorize. You can use the quadratic formula like I've done, and there's absolutely nothing wrong with us getting x-intercepts that need to be rounded off. Okay, not everything is going to be a perfect neat little integer. All right, any questions on I? All right, so yes, absolutely. So if we did question J as our answer, again, we do not know what a linear factor is. So that means that we would have had to sub in order to be able to work out what a linear factor of this expression is going to be. And as it turns out, if we sub in 2, we get 0 as an answer. Okay, so that means that x minus 2 is a factor. And then as it turns out, this is also going to end up having irrational roots like the previous one. So here we would end up with ax squared plus bx plus c equals 0. We would have then been able to work out that ax cubed equals 1x cubed, so a is equal to 1. If we work out b, we've got bx squared minus 2x squared is equal to -3x squared. So b minus 2 is minus 3. So that means that b would be equal to -1. Let's see, Belinda. Yeah, I get the same answer as you, Belinda. Yeah, 100%, 100%. Okay, and then in this case, we would have ended up with minus 2c is equal to 6. So c would end up being equal to -3. So this would end up in that, and x squared minus x minus 3 equals 0. So again, this doesn't factorize nicely. So either x is equal to 2 or x is equal to -b. So that's -1 plus or minus b squared minus 4ac all over 2a, and therefore x would be equal to, as Belinda said, 2,30, or x would be equal to -1,30. Yeah. Let me just move that up a little bit. I'm writing it right down here at the bottom. I don't know why. -1,30. Okay, good job. Well done, everybody. How are we feeling now? Are we feeling a little bit more confident when it comes to solving cubic equations? Cool, Oratile. Thank you. Nice, Morankoa. Good, Loretta. I'm glad you feel a bit better. Okay, so what we've just practiced is solving cubic equations or finding the x-intercepts of a cubic function. That's what we've just practiced doing in this section. All right, so what I want to try and do now for the remainder of this lesson is just discuss the cubic function with you a little bit, all right, and try and tie what we're seeing in these solutions to what you see in the cubic function. Okay, so every cubic function is going to take the general form ax squared, ax cubed plus bx squared plus cx plus d. All right, and in this form, the value of d, okay, that is always going to be our y-intercept. Okay, so if the d term is not there, it means that the y-intercept is 0. Okay, so the constant on its own is the graph's y-intercept. The other thing that's really important for us is the shape of the cubic function. Now, the shape of the cubic function depends on the sign of the coefficient of the x cubed term. So if a is positive or if a is negative. If a is positive, so if a is positive, the graph is first concave down and then, oh, that's a horrible cubic function, is first concave down and then concave up. Okay, so when I say concave down, this bit over here is concave down. Okay, then the graph changes and it now becomes concave up. That is now concave up. Okay, so the yellow bit over here is what we refer to as concave down. And the green bit, when the concavity changes, now it is concave up. If A is negative matrix, then the graph is first concave up and then concave down. So it kind of does that. All right, so the other way that you can look at this is that it has been reflected over the x-axis. Okay, so here it is first concave up. That's this bit there, concave up. And then that changes and it becomes concave down. Okay, so concave down. So very important that we understand and learn that the sign of A affects the shape. You have to know that, right? There's so much more going on here though, other than just those two things. And that's what I want to talk about for the rest of this lesson. Okay, so let's pretend that we have a cubic function, okay, that is first concave down and then concave up, right? What it also has in this particular case over here is that it has two turning points where the graph changes direction. Okay, so when the graph changes direction, those are called turning points. Okay, so the graph changes direction. And you will also find that there is a change in gradient. All right, so what we would see for this particular function is that before the first turning point, the gradient over here is positive or negative, guys? And it's the same over here. The gradient over here is positive. Okay, so in other words, when we say a positive gradient, it is increasing. So we are basically walking uphill. So we've got a positive gradient. Okay, we are walking uphill. There's an increasing function where I've colored it in green. Okay. Between my turning points for this particular cubic function, it is now decreasing. All right, so between my turning points, it is a decreasing function. So here in orange, okay, it is a decreasing. So sorry, it's a negative gradient. I'm walking downhill. No, I don't want to add a pen. Negative gradient. It is known as decreasing. What is the other name that we give to gradient? What's the other name that we give to gradient in this case? There we go, the first derivative. Yes, lovely, the first derivative. So the first derivative is the gradient at a particular point. So the other way of us being able to write that the gradient is positive is like this. F prime x is greater than 0. Okay, so f prime x is greater than 0. Over here, where the gradient is negative, f prime x is smaller than 0. Correct, it is the first derivative. What is happening at the turning points as far as gradient is concerned? What is f prime x equal to at the turning points? Exactly, it's equal to 0. So f prime x equals 0 at our turning point. F prime x is equal to 0 at our turning point. All right, so our graph changes over time. Okay, it can be increasing, then we have our turning point where gradient is 0, then it's decreasing, then it's increasing again. All right, so these are important characteristics of what our function can do. So that is the first derivative, the gradient at a particular point. The other thing that we need to take into consideration when we're looking at these graphs, all right, is concavity. Okay, now that is a new word for us in matric. We don't talk about concavity before we get to matric. All right, so I'm going to draw, that's actually a really horrible one. Let's draw something like, okay, that's not a huge amount better, but it'll do. Okay. All right, so this particular graph, I'm sticking with the same theme as what we've got up there, right? This graph is first concave down, and it's concave down all the way to a particular point called the point of inflection. And at the point of inflection, the concavity is 0. And then your graph changes from being concave down, in this case, to being concave up. And here the graph is now concave up. All right, so just like the first derivative, the gradient is 0 at the turning point. The second derivative, the measure of concavity, okay, the second derivative is equal to 0 at the point of inflection. So at the point of inflection, we have 0 concavity. At the turning points, we have 0 gradient. Okay. When the graph is concave down, the second derivative, I hope you guys can see that, is negative. That is when the graph is concave down. Okay, the second derivative is negative. When the graph is concave up, your second derivative is positive. Okay, and that's one of the ways in which we can test to see whether a point of inflection is in fact a point of inflection. Okay, is by looking at the sign of the second derivative. All right, is everybody happy with that so far? Does that make sense to everybody? Are there any questions? Cool. All right, so it's very important that we look at our function good stuff. Good stuff. So there's actually, this is probably the one I should have done first, but anyway, it doesn't matter. We can do this one last of all. All right, I'm just going to draw one more cubic function, and now I'm going to draw the x-axis. That's the x-axis. So the other thing that they can also get you to look at, okay, they can get you to look at f prime x equals 0, or f prime x is greater than 0, or f prime x is smaller than 0. So that's gradient. Then we can look at concavity, which is your second derivative, right? What are we talking about if I talk about f of x being equal to 0? What does that mean? Okay, so that's what we've been doing this lesson. When we say f of x is equal to 0, we are working out the x-intercepts. Okay, that's what we've spent this whole lesson talking about. All right, can you see how it all fits together here? I should have probably started with this. Okay, so where f of x is equal to 0 are the x-intercepts when they ask us to solve a cubic equation. If I say to you for which value, so let's pretend that value of x is -1, and let's pretend that's 2, and let's pretend that one's 3. These are the x-intercepts, right? If I say to you for which values of x is f of x greater than 0, where is f of x greater than 0? Okay, where is y positive? Y is positive above the x-axis. So it's going to be between here and there, or bigger than 3. Does that make sense to you? That is where y is positive. Okay, if I say to you, where is y negative? Let's choose another color. Where is y negative? You're going to say below the x-axis, isn't it? So y will be negative here, or between those two. Okay, so you can look at your graph, all right, in terms of 3 things. y output, which is this last situation, or the first derivative, gradient at a point, or last of all, concavity. Okay, and it's all three of these things that we're going to take into consideration when we sketch and analyze these particular graphs. Okay, I hope that that's given you a nice little overview of the cubic function. And yeah, it's just sort of explained a few things that you maybe didn't understand. And then next time we can launch straight into how do we actually sketch these. Okay, I think there's a poll that needs to be done. And then of course, if there's anybody that hasn't done the quiz yet from last week, please, we need you to do the quiz as well. Okay, so please answer the poll and then we can say goodbye.
The link for the diagnostic quiz is on the chats. I've put it on the chats.
Thank you, Neliswa. Sure, can you see there?
Ma'am, on last week's quiz, we had a question that said, given that f of x is equals to negative x squared plus x plus 6, determine the x-intercepts of f.
So if f of x is equal to negative
x, negative 2x squared.
Negative 2x squared.
Plus x plus 6.
Yes.
And they told us to choose between the three answers. And ma'am, none of them
worked out. Okay, that could have been an error on my part. I don't actually even remember that as a question. How terrible is that? Okay, so if that is indeed the case, we would have made it equal to 0 in order to be able to solve it, wouldn't we?
Yes, ma'am.
Okay, and then the easiest thing for us to do, if this doesn't factorize, which is fine, we can use the quadratic formula. So let's just go and have a look at, just move this over a little bit. Can you see how terrible is it that I can't even remember that? I mean, I obviously said that. And I can't remember. Okay, so x is going to be equal to negative b plus or minus b squared minus 4ac all over 2a. All right, just give me 1 second. Let's put that into my calculator.
Ma'am, the answers that I got were negative 3/2 and 2.
Okay. I get 2, so I get x is equal to 2 or negative 3/2.
Yeah,
Was that not one of the options?
No, ma'am. We had one of the options that were almost close to it was negative x is equals to negative 3/2 or x is equals to 1.
Oh, okay. So I obviously made a typo there. All right. Sorry, that 1 was supposed to have been this 2 over here.
Yes, ma'am.
Okay. All right. My apologies, can you see there?
No problem, ma'am.
Sorry, my darling.
Thank you.
Okay, no problem. Thank you for pointing that out, okay?
Yes, ma'am, no problem.
All right. Take care. Thank you. I'll see everybody on Thursday, all right? Bye, Matrix.
Bye.
Bye, everybody.
Bye,
Unless there are
ma'am.
any other questions you want to ask. Bye. Bye, Belinda. Bye, Oratile. Thanks, Pumeza. Thank you. Bye. Bye, Kashandra. It's nice to have you with us again. Mohammed, was that okay? Did you follow what I was doing, or is this a little bit overwhelming for you today? Oh, it was a nice lesson. Oh, I'm so glad you enjoyed it. As I say, I'm sorry. Okay, well, that's good. That's good. I'm glad you found it straightforward. Obviously, your teacher will do this with you at school. But what we try and do, Mohammed, is we try and follow the department's term plan as much as possible, because we kind of figure most schools would be working according to that, although not all of them. So yeah, there are a lot of schools that have actually already done calculus, but yeah, it doesn't matter that your school hasn't. Factorizing is easy. Okay, cool. I'm glad you enjoyed that. Anyway, it was really nice to have you with us, and we'll see you on Thursday. Have a good week. Just graphs. Yeah, no, the graphs are different.